Welcome to the Building Science Podcast.
Welcome to the Building Science Podcast.
Bringing the human factor to construction, design, and architecture. Brought to you by Positive Energy in Austin, Texas.
Okay, hello and welcome everybody. This is the Building Science Podcast. I'm Kristof Irwin. Today I'm really pleased to introduce to you two guests and friends and colleagues of mine. I have Keith Simon and John Posenecker, both with Building Exterior Solutions. And I have asked them to introduce themselves. So I'll start with you, Keith.
Thank you, Kristof. My name's Keith Simon. I'm an architect, but I currently work as a building enclosure consultant. So we consult on the design, construction, and testing and investigation phases of a project. I'm also on the adjunct faculty at the University of Texas School of Architecture, where I teach a technology course called Environmental Controls.
Awesome.
And I guess that's about it.
And then so also with Building Exterior Solutions is John Posenecker. So John, tell us a little bit about you.
I feel like I'm the older member here, but went to school at Auburn University. I'm a registered mechanical engineer. Spent 15 years in the nuclear power commercial design business, and then moved over to work for a family member in acoustical contracting, noise control, studio specialty work. And don't work for your family, but ended up working for a roofing, waterproofing contractor for 10 years, and I moved over into the consulting world, back into the design world, which I'm really having a lot of fun with.
Yeah. We were doing a little bit of math just before we started recording here, and between the three of us, we have something like 75 years of perspective, and there is a lot of depth to the different things we have perspective on. So today's podcast has really one central theme, and it's about delivering good buildings. And by good, I think we all know that the term nowadays is called high performance, right? And high performance means they are lovely, they last a long time, they don't use much energy, they're comfortable, and they're healthy. And today we're really going to focus on that. They last a long time, they're durable. Because I guess the seeds to this podcast came about from the three of us just talking over the last few years about the things we see and about, I guess you could almost call it bearing witness to what happens in the building industry these days. And I'm going to encourage us all just to keep things positive, because there's a tendency just to get down on how things go. So I want to just say one more thing, and then we'll let these guys dig in. But we as a company have started what we call the Building Science Philosophical Society. And it sounds like a flowery name, but bear with me here, because there's actually some thought behind this. We have been doing every 2 weeks building science seminars here at Positive Energy. And we've been doing those on technical subjects, but I think all three of us would agree right now that we don't really need to invent new products. We don't need to invent new systems for buildings. That's not the problem. It's not like there's something missing. What we need is I guess two things. And this is what we're going to talk about today. We need to figure out not what to do or why to do it, but whether or not to do it, right? Why is it that the public doesn't ask for it, that our owners don't ask for it, that project teams don't seem to really focus initially on durability or health or comfort outcomes? There's across our culture almost, across our economy, there's a focus on first cost, and I think that's going to be coming up today. So first thing we're going to talk about are the need for consultants on projects, right? So we know, right, structural engineers are on every project because buildings shouldn't fall down. So Keith or John, what do you think about building enclosure engineers?
Yeah, so one thing that's of particular note, you may have noticed my background's as an architect, John's as an engineer, and if you look at the backgrounds of the 25-ish folks at BES, you'll find a variety of backgrounds, a lot of folks from contracting and the trades, and that's by no means a coincidence that in this country, there's generally not a specific way to study this field of enclosures and building science.
Right.
You can come at it sort of from these other areas of structural engineering, other engineering, architecture, but we fall here because of our interest and we fill a void. And it's a real void in this country. And I say this country because there are other countries like Canada and places in Europe where you can specifically study building science.
Right.
And when we meet those folks at conferences and other places, it becomes apparent how much of an advantage that is.
Mm-hmm.
So it's a real need and a void that's in our industry right now. And it's a real important one. And so I don't know if, John, you want to talk about some of the services we actually provide.
Yeah, I can do that, but what you're saying is so true that I think other countries look at long-term quality and long-term buildings. We in this country seem to look at short-term benefit, and the majority, I would say, of the buildings that we work on most likely will be sold within the first 5 years.
Yeah,
and
that's
the
a big factor.
The interest is getting past that time to sale, not in building a quality building that's going to last 100 years. Mm-hmm. So it's a completely different focus on the intent. And I think that really affects the process we follow and the quality of the product.
Mm-hmm. And so before you go into the different...
So instead of getting negative there, but there's a lot of positive opportunities that we can change that. It doesn't always have to conflict.
Right. And, I think it's really profound, and there's almost like a subtle level at which the buildings around you affect your experience of where you are, right? So we know, a lot of the retail spaces, they're kind of built to be disposable. They're going to last a few years, they're going to sell stuff, and then they're probably going to be torn down. Maybe repurposed, but probably torn down. And what happens is the construction practices, and I'm thinking specifically on the mechanical system side, but I'm sure the enclosure side too. If a building is destined to be torn down, it's kind of built with that in mind, that's going to inform how it gets built. And then we have these trickle-up construction practices where those trades work on other projects. But John, so what are the type of things you do for projects? Or what were you going to say?
Well, I was going to say a lot of it is driven by the owners. And when you have an educated owner, the owner can see the value in long-term and quality of the building. Mm-hmm, mm-hmm. Or if it's an owner that's purchasing a building, he can also see and reflect, and there's a benefit there.
Right.
So as we educate owners, I think that helps the industry.
Mm-hmm. So they're going to have reduced maintenance costs. They're going to have a building that just lasts longer from the start. They're going to have better health and comfort.
Their liability risks go down too.
Mm-hmm.
Because anytime you have water intrusion in a building, ultimately your insurance or litigation starts from your tenants.
Oh, yeah.
And so there's a lot of risk management associated with it.
That's a really good point. Keith?
So just want to interject and maybe define enclosure. Some of the listeners may not know what we're talking about when we say building enclosure.
What's an enclosure?
And so an enclosure, in its most basic form, we're talking about roofs, wall systems, fenestration, so the openings like doors and windows and storefronts, curtain wall, anything that's similar to those kinds of fenestrations. And then below grade waterproofing under slab, balcony waterproofing, stuff like that. Now that's it in a simple sense, but then it gets pretty complicated pretty quickly because we're talking about how all of those enclosure elements control the flow of heat, air, moisture, like bulk moisture like rainwater, and moisture like moisture vapor.
And sound.
And sound and light and a whole bunch of others. And so this term you mentioned, durability. Yeah. Durability is, I would say, a piece of sustainability, a really important component of the term sustainable design. And that's kind of what we focus on because, the finishes of a building are the first to be thrown out and redone. Maybe the mechanical systems are next, but the enclosure is your most long-term vision, at least hopefully, theoretically, or could be. You couldn't look 100 years into the future. And so what we focus on is making that long-term durable solution. And it's interesting, too, because sometimes when we're looking at the durable solution, we come at odds to other folks in the green movement. I mean, one example is with roof membranes, where a lot of folks in the green movement may want a white membrane for its reflectivity and energy efficiency, whereas when we do our hygrothermal modeling, we can see there's actually a lot of benefits to black membranes and drying it out and preventing conditions that are favorable to mold growth. Or, for example, we see that the white membrane, after 3 to 5 years, is just as dark as a dark membrane. And then we would want to focus on the amount of insulation that, in terms of energy efficiency, we believe that's more of a critical component. So we're not cut and dry with our recommendations, but just the point that this element of durability sometimes falls in conflict with other things, other factors going on in the job other than just, say, money, for example.
Right. You guys get involved, and we talked about, I was trying to use this kind of threefold logic. One is structural engineers are on every project because we know it shouldn't fall down. But where is the focal point for the fact that the building shouldn't rot, leak, or fall apart over time, that the enclosure shouldn't? And then similarly, who is the focal point for the indoor health, the indoor air quality, the comfort? It's way more than just heating, cooling. But what about that point about is it reasonable that design teams should expand right now, or is it the architect should just know all this?
So if you just talk about maybe what a building envelope consultant does over the process from design to construction.
Okay.
The early stages of design we rarely get involved in, but that has a little bit of involvement makes a big difference in starting the project off right for your envelope.
Absolutely.
Because you can define what the options are for materials. You can define the areas that are critical to the envelope.
The connections and things.
And then start off on the right foot and work through the design phases from the schematic through the details.
Right.
A lot of times we get involved at the end of the details, right before construction starts. And at that point, budgets are set, contracts are let, very difficult to make any changes. So there's an opportunity in the early design phases to get things started correctly.
Right, yes.
Then from the design phase, we move into construction and we monitor the submittals to make sure that what was designed is what is being provided. And then as it's built, we monitor the construction to make sure it's installed per the design and the submittals. And then we'll actually do testing at the end to prove that it performs as expected. So in a nutshell, that's kind of what the consultant does.
The other piece of our services that we do is failure investigation, which it's an unfortunate situation.
Unfortunately, yeah.
But on the other hand, it's something where we can usually by the time they've called us on a failure investigation, they're at their wits' end. It's a tough solution because the contractor or the architect or the owner, whoever it was, simply could not figure out how to solve their water infiltration problem.
And we should say it's unfortunate when the building's 2 years old.
Yeah.
When the building's 50 years old
That's a
and they're renovating, it's really interesting to see how the old construction performed so well for so long. And then we look at how to upgrade it.
Yes, and unfortunately, at least half of the failure investigations we do are of brand new buildings. When I say brand new, say within 5 years of completed construction. But that those failure investigations very much inform what we do, because when we're now then go back to consulting on the design phase for the drawings and the specifications, we can make our recommendations based on we have seen this work, or we have seen that this does not work, and we believe this is a better way to do it because of that. So this goes back to the problem of process. And one of the things that we've seen as a process issue in the industry is that most architects, and I know this from my experience, even from a architecture firm with a national reputation for sustainable design, that the main way an architect starts a new project is by copying and pasting wall sections and assemblies from older projects. But with a few exceptions, and there are some architecture firms that do monitor and go back and check and survey and measure, but most of them, there is no feedback loop. So there is no checking to see if those decisions they have been making for maybe years and generations are actually good ones.
Yeah.
So the failure investigation that we do is a really sort of critical part of making these projects better that we're working on.
And that's actually one secret part of what we're doing today, is trying to feed that information back.
And I was going to say, from a contractor's perspective, I can't tell you how many times for the same architect, we do several different buildings over a period of time, and we make the same comments and write the same RFIs and change the same details and modify and make substitutions to the same specs. And over a 10-year period, they continue to copy and paste the same things.
Yeah.
And I think it boils down to either most of the time they don't understand is probably the case, or they don't care one.
Yeah, but let's hope it's the former, not the latter. Because I think people do care if they're given enough information to know why they should care. And sarcasm alert here, everyone, that doesn't happen on mechanicals. They never cut and paste on mechanical systems. It's never done the same way again.
But it's natural when you're under the gun and have a short budget and push to get product out. That's how you do it.
Yeah, and there you go. That's sort of the elephant in the room here, is that first cost is so important, and it's like steering a super tanker, right? It's not just public perception, but generally speaking, all the various players, the financial players, the insurance, the legal, the contracts, everything has a certain set of expectations for how much a building's going to cost, how much a square foot's going to cost.
But if you think about, on a commercial job, the envelope portion of that cost is maybe less than 5% of the construction.
Yeah, that's a good point. Yeah, mechanicals are often...
But I believe the number is somewhere between 70 and 80% of construction litigation is related to water infiltration at the envelope.
Yep, absolutely.
And so the long-term cost, and when we get involved in the litigation cases, and you look at the time and money spent with
and the pain,
with the legal people,
mental, emotional
evaluating
cost.
These problems, if just a percentage of that was taken and put on the front end of a project, it could be avoided.
Mm-hmm. So
those are some of the frustrating things. How do we change that model?
And so let me build on, or give a specific example to what John's talking about. And I love this term, bearing witness, that I heard Kristof use it to describe what we do. And then I've repeated it many times, because while we're frequently brought in to solve the really tough challenges by virtue of what we do with construction observation and peer review, we are bearing witness to common mistakes that are made in the industry.
Right.
And so whereas something like 80% of construction litigation has to do with water infiltration, I don't know what the percentage is, but I know a large percentage of that happens at the windowsill. Window flashings done poorly. And so we see in all the peer review we do, more often than not, the architect does not correctly draw the windowsill flashing. It's a very small percentage that's drawn correctly. Most contractors can make up for it by just simply knowing the installation practices or by providing an RFI. Mm-hmm. But many contractors install it incorrectly too. So we're on site, we're involved in the design process to make sure it's drawn correctly and specified correctly, but we're there in the construction process catching the mistakes by the contractors. It makes us a little bit nervous. This is one example of when we're not on a job that you're just kind of you're crossing your fingers and hoping it gets done right.
Oh, yeah. Yeah, a lot of, I think, there's lots of beyond code programs out there right now, and they rely on, or for the most part, they're relying on really good recipes, really good checklists, really good lists of proper materials, and then wishful thinking. Right? There's no way around it. If you don't check it, if you don't watch it get installed, it's just...
Well, and you think about the guy that's installing the product in the field, and I'll stand up for contractors a little bit, because you've got a guy that's making somewhere from $10 to $15 an hour installing that sill. He doesn't probably have the documents in front of him.
Yeah. Or
if he does, he's going to install what's drawn, and nowadays it's pretty minimal. Mm-hmm. You don't have the craftsmen that you used to have installing product, right? So it's understandable how that happens. And is it the fault of that guy or the contractor that he's installed wrong, or is it the fault of the architect for not detailing out those details properly? Right? That's the difficulty.
Well, legally, if it's an omission, the contractor should theoretically submit an RFI and ask for a detail, right?
If he's a good contractor and he has somebody in the field that recognizes that he's doing it wrong.
So how specialized is that? I mean, the actual hands that are installing that windowsill flashing, they're doing all the control layers. Excuse me. They're doing all the water resistive barriers, right?
So usually the guy
building.
actually physically installing the product is a fairly lower level labor person. He has some experience in installing product. The key is the foreman or superintendent of the job for that contractor to oversee what's being done. But like everything else, it's such a competitive market now that you have to limit that. You don't have full-time superintendents or foremen a lot of times on the job.
Interesting.
They'll stop by once a day or 2 or 3 times a week, and you've got a crew installing. So if they start off wrong,
Do they do mock-ups? I mean, I guess depends.
a good job will do mock-ups.
Yeah.
And
And
you'll
make
have
sure
a
everyone's seeing them.
manufacturer there, you'll have a consultant there, you'll have the design team representative there to make sure it's installed the way it's intended.
We feel that pre-construction meetings and mock-ups is definitely a critical component of a good process, and so we'll on the jobs where we're involved, we'll make sure to have pre-construction meetings and mock-ups for, like, say, waterproofing, below-grade waterproofing, balcony waterproofing, roofing, lath installation for stucco, so any critical components like that. That being said, it's not a silver bullet in and of itself, because let's say we work with the foreman. He's great. He works with us. He gets it. He finishes building 1 of building 7, and then building 2 comes up. It's a new foreman. It's a new crew. There's been no communication between the two, and it's like starting from ground zero again. We see that issue all the time, and so that's why. If it's a job like that with 7 buildings, we make sure to be out there at the beginning of every single building, so we're making sure there's continuity.
And that's part of where it's not maybe like craftsmen used to be of years ago, that they were consistent and that was their living, right? A lot of these guys, they do this for a while and go do something else.
Right.
It's not that craftsmanship
Yeah.
that used to be there.
It's tough work, too. I mean,
And the other side of it is the products. It used to be really simple products.
yeah.
Right, you had building paper on the wall, or now they're pretty sophisticated products that are not as simple to install, and the systems that all tie together are not as simple as they used to be.
Yeah.
So you get that complication, which are really probably superior products, but you need the quality installer to understand all that more, right? And so there's a little.
There's incompatibilities
Missing
between
there,
certain
yeah.
products, and there's primers.
The issues we see, the failures or deficiencies that we typically see, are usually not in the field of anything.
Right.
It's usually not it's rarely an actual product or system failure. It's the penetrations, the terminations, and the transitions.
Exactly.
It's basically all the joints. When one material hits another material, one system hits another system, that's where the danger lies.
Right.
And where you used to have one type of product, say on the wall air barrier or water resistive barrier, whatever you want to call it, across the whole building, now you're losing that, where you have 4 different types of cladding on the building, and now the cladding manufacturers require you use their products, which means you have, say, 4 or 5 different systems that all integrate. And along with that, there are different contractors installing those systems. So not only are the multiple systems in that integration, but different contractors at different times trying to tie it all together. The complication makes it that much more difficult.
Right.
And that's where you see a lot of problems.
Yeah, that's true, John. It's not just a joint between products and systems. It's the joint between subcontractors.
Exactly.
And so whenever we have that joint between subcontractors, penetrations is a classic example, because the framer, let's say they're doing zip system or wall membrane, goes up and puts all the sheathing on, puts all their membrane on, and then there's the mechanic or plumbing subcontractor penetrates for the hose bib, and the electrical subcontractor penetrates for all the electrical devices, and the signage guy, and there's all these different contractors poking holes in it. Are they each going to be educated on how to flash those penetration, or is somebody else come through and flash all those penetrations before the cladding guys go up? Well, what we usually see is the cladding guys putting it up and then we dig through their cladding to find out that nobody's flashed the penetration. That's a really common mistake we see.
Yeah. Mm-hmm. So how do we fix that? You know, I didn't mean to start thinking about public perception other than from the angle of, because all the fixes I can think of mean that it's going to take longer, there's going to be more oversight, and anything I can think of that's going to try to address this very commonly flawed process. So commonly called as normal, it's going to cost more.
I think what we were talking about earlier today about you always have a civil engineer, a structural engineer. You have an MVP engineer.
Right.
I think as people realize the magnitude of the envelope products and the risk associated with those long term and the impact it has on the quality of the building, you'll see more and more of the integrated design bringing that envelope design person into the fold early in the design phase. And that's kind of what we were talking about earlier. I think that's really important, and it seems to be the natural progression of where we are now. But the design world has to start accepting that, I think. But it can be driven by the owner. I've seen several owners out there now that have very talented construction type people in charge of that design phase. And they will bring in the appropriate people to help early on in the process.
Right.
That makes a big, big difference.
Yeah. I think that's huge. I think the idea that, you know,
then you flow out from there, right?
Exactly.
The design's done well. You don't have problems through the contracting phase for your subs and the submittals, and then when you get in the field, you minimize to the best you can unforeseen things, right? So you've built them in on the front end.
Yeah.
Because the last thing you want to do is design the building by RFI in the field.
Exactly. And that's
it's
common.
Quality,
and
it kills quality, it kills schedule, and
it
costs a lot of money.
Yeah, and that's the thing, is that I didn't want to, I was thinking that it was going to be that there's no way to fix it without spending more money. But if you think about the money spent over time for the delivery of a building, or even, let's say you say the money spent over time for the first, pick a number, 20, 30 years of a building. Oh my gosh, if you front load the design process with a lot of effort and a lot of thought and a lot of integration, and then maintain that strong front loading. You know, if I'm thinking of a 20, 30, 40, 50-year building life cycle, if I've really done a good job on the construction at the front end, that's going to dramatically impact.
Yeah, Kristof, you and I attended a presentation by Sam Rashkin of the Department of Energy, and he talked about saying partial cost versus full cost of a project. And if we talk about, you know, the upfront costs, we shouldn't be only talking about upfront cost. You know, it's a partial cost. And so we, you know, when we have a potential new client, we frequently have trouble articulating the value of our potentially what they see as expensive fees up front that they don't have to use. You know, they've done lots of projects without building enclosure consultants, so they don't have to use us. They may like to, but, you know, our fees may seem high. But the clients who've been through the ringer, whether it's litigation or tough repairs that they had to live through, and their you know, tenants had to live through,
or cost overruns during construction, or schedule delays, or all those problems.
Yeah,
I mean, we can easily save $50,000 mistakes, $100,000 mistakes, and that's before we're talking litigation. Then we can easily save $500,000, multiple $1 million. So if you look at the full cost and not the partial cost, it's when you do that, we're sort of a bargain, I think.
Yeah. I do think that consultants in your field are definitely needed. I think that just like a kind of a comical perspective, or maybe it's realistic. Like the way buildings are delivered very commonly right now, it leads to these rashes of forensics, right? I mean, I'm doing 1 to 3 a week of moisture intrusions, and I'm doing mainly residential. And the same thing. These are not old buildings. These are buildings 2006 to 2010, very commonly.
Well, it's not so much an advertisement for a consultant to be involved in the front end, because the way I look at it is we can be involved in the front end, or we will be involved in the back end.
Yeah.
You see the
gravity
changes in construction that go in and how it's built. To me, that's money in the bank. Mm-hmm. Because we'll be involved later, or somebody from the consulting side will, to fix it.
Absolutely.
Yeah, I mean, Well, it's in our name, Building Exterior Solutions. We pride ourselves on working with the project team as best we can to deliver a successful project. But things sometimes we're not brought in there or whatnot, and so we always say, we don't look for litigation work, but it finds us.
Right.
And right now you're right about the waves of litigation. We're seeing a multifamily litigation wave come through that, a few years ago, a massive wave of multifamily building began. And it's interesting because the multifamily contractors are not quite your single-family residential contractors, and they aren't the commercial contractors, and they're stuck in this world of not understanding the construction practices required. And so there's been quite a bit of learning pains as that sort of industry is developing.
Oh, absolutely. I personally have stopped off at several job sites over the years where I drove by that job site every day, or rode my bike, or walked my dog, and I just couldn't not say anything anymore. And finally I see someone working on the job site, and I walk up and I point to a balcony flashing that is, there's 50 of them right there. And I usually get off this job site immediately, and some sort of strong language attached to it.
Yeah, no, I can relate
and then
to that.
One of them is a project I saw you guys consulting on recently. I'm like, yep.
Well, I see stuff all the time being done wrong, and it's frustrating because you want to help.
Super frustrating.
And yet at the same time, I know if I go up to a construction site where it's not our job,
or take a picture,
that I will not be received nicely.
Right.
That's a nice way of saying that there's a good chance somebody might try to punch me in the face. So, so I usually just keep my distance.
Yeah, I've had the same experience. Just not being punched in the face, but hostility, tremendous hostility. Like somehow I'm an attorney or I'm an ambulance chaser, I'm going to try to get them. I'm really just if you've tucked your raincoat into your underpants right there, you need to pull that out. And it's kind of like that. It's kind of like, those of you who love cars, what if you had secret knowledge of cars and you knew that every car on the road that we want to be fuel efficient had the emergency brake half on and the driver didn't know, right? It's kind of like that, knowing the secret vision that you have of buildings. All right, so we've talked a lot about the problems that we see, and I was actually thinking at the beginning of this interview that we were all going to agree that the fix was buildings need to cost more. And I'm not sure, which, it's disappointing, but the public has accepted that with food, right? People, I think, are spending more for organic vegetables than they used to, and used to be the food industry fed us and the medical industry fixed the problems that the food industry might have created. And cars cost more generally than they used to. I don't know. Yeah, I bet cars cost more on a per capita average income basis than they used to. So maybe buildings could start to cost more. I mean, a production home is delivered at $40, $50, $60 a square foot.
But I think you.
So it's not money. Is it?
You can't just
What's
look at cost to judge everything, but it's maybe try to talk in terms of value.
Value. What do you mean by that?
So a mix of quality for cost, right? So
You'll
not
spend
everybody can afford the high end Lexus, right? But you can get just as reliable and value to an individual at a lower level. Car, right?
We need to be careful if we mention a brand with lower level. But it'll still drive you around, keep you warm, keep you cool in the summer.
Right. So you have to look at what is the owner, I guess, or the end user's value point.
Well, there's a little bit of a disconnect sometimes. The owner makes the decisions that affects the energy bills or health of the occupants.
Yeah, and just because you spend more money doesn't mean you get a better product.
So it's process?
I think in the end, in my mind, it's the process you follow has the most opportunity to improve the value of the product. We spend a lot of money on the back end of construction or during construction trying to understand the design, fix the design, whatever you want to call it, where if we built that in the front end, maybe it would save money in the back end of construction.
So you're saying you take the money and hassle and pain at the back end and well, maybe not move the pain to the front end.
Do some work on the front end to prevent that and the cost and schedule problems you have.
So you front load the project.
Right. I think that's where we're.
Yeah, so if you're looking at the full cost, it's not a more expensive project. It's actually a less expensive project, but we have to wrap our minds around thinking about it differently, that we're going to spend more money up front to prevent the maintenance costs, the energy costs, the repair costs that are going to come down later.
And that's a separate thing from the construction cost versus the maintenance and long-term costs, right? There's two benefits you get out of designing it properly. You save in the construction, and you save long-term in the quality of the building by the energy savings, and durability and longevity of the building, right? So it makes a lot of sense, and when you talk to people, everybody agrees with that. But practically speaking, our process that we typically follow in a competitive type world is conflicted with that thought, right? It doesn't incentivize front-loading the project.
Well, didn't you just go back to money a little bit, John? I mean, competitive. What was the basis of competition?
It's the false concept that when you bid a job out competitively, you save money.
Mm-hmm.
Because in the end, you do save money maybe in your initial contracts, but in the long-term construction of the building, you lose money in the time and the changes, and ultimately in the quality of the building built. Right. Where if you had an integrated design team in the front end, which really has to be driven by the owner, I believe, you don't worry so much about that competitive bidding process, because in the end, professionals nowadays know what things ought to cost, and you know if somebody's out of line in their pricing. But you could get a team together of all your subs and to design and work together in the front end through schematic design construction documents and have your budget set so when you're ready to say go, there's no surprises in the contracts you have to award. And then you've got a design that's ready to be built without a lot of changes through the construction phase. And it runs smoothly. There's no holes in scopes between the subs because they've all been involved. And it's really funny about that. You recently, the general contractors have started going through, say there's 10 drawings of details. And let's say there's a dozen details in each drawing. And each detail has 20 notes about different components of that detail. And they're going through the effort of having all the subcontractors involved, going through those details and highlighting by color or some way designating which trade has each piece of that note.
Wow.
And it's really amazing how many are not included in anybody's contract. So now you have to go back, and those are scope gaps.
Wait, you're saying there's details that are drawn that aren't in any trade's contract?
Well, is it the window guy, the metal panel guy, the air barrier guy, the caulking guy, the sheathing guy? All of a sudden you realize nobody has that. Well, somebody has to pick it up. Somebody has to build it. And you get in that sequence discussion and who's responsible. And that's where change orders flow out. Well, if you understand change orders, they're a lot more expensive than they are in the original pricing that you do at a project. So if you can eliminate all that, you save the time and effort going through and fixing it.
Beautiful.
So it makes a lot of sense. And when you talk to people, they all say yes, but we just can't do it that way.
And why? What's the holdup? Why can't we shift?
That's the frustrating part.
I don't know.
And I think one part of it, if you have an owner that mandates the process, he can make that happen.
So an engaged
the designer can't. He doesn't make those decisions. The general contractors can't. They don't make those decisions. The subcontractors can't. I think it has to be somehow the owner. And it's got to be an owner savvy in construction. Nowadays, a lot of owners are more financial based and don't understand construction. So their focus is on what is the cost. And that's not the right focus.
Right. Well, Keith, I can see you want to say something. But an architect, I have a question for you. So within the architecture profession, we have owner's project requirements that lead to basis of design. So the owner doesn't have to be a building science consultant or a building science aficionado or an integrated design, expert to get a good building delivered. And I'm not saying that's what you were implying, John, but you were saying the owner's wishes needed to be translated into some actions that change the process. And I'm thinking that the architect is well positioned in the industry to lead a design team, to do an OPR, owner's project requirement. What do you think?
Yeah, absolutely. And, when you going back to the basic question of like, how can we sort of go to the root of some of these issues and solve things? I believe that there is a major problem in architecture schools across America today. And, architecture schools focus so much on innovation and ingenuity and the kind of design that's very unique and pushing the envelope, no pun intended. And, people like Zaha Hadid or Frank Gehry, who make, frankly, really bad buildings, are emulated. And this goes back to earlier what I said about a lack of building science education in architecture schools today. But it's also I believe it's a need for a change in priorities. And, when I was in school and we were having all Peter Eisenman or like people like that shoved down our throats, and what was more interesting to me was vernacular architecture. Architecture without architects, ancient architecture that had no architects involved. The everyday stuff was what was most fascinating to me, which is another reason why I love the term used to describe what we do as bearing witness. Like, even today, the sort of common patterns or mistakes or practices that happen in the industry, that's fascinating to me. And how can we improve those? And I think that prioritizing that in the schools of architecture, understanding that, will help position architects in the industry to be able to address those sort of common pitfalls.
And I think that's a huge point. I think that's huge. And it was bold to say it, I think, in some ways. Because you are an adjunct professor.
I'm an adjunct professor at the university, and I'm a licensed architect and spent most of my career as an architect. So I could be accused of being a self-hating architect, but it's a problem that I do believe exists.
Mm-hmm. And to John's point, it does get done. I mean, of front-loading the process and delivering good buildings. Well, actually, I don't know if what you were describing, this I think of it as front-loading the effort and design thinking. But my point is that there are examples of fantastic buildings that are getting done very well, and I don't know how they would compare.
So if you look back at those buildings, who drove the boat? Right? Who was on the front end making the right decisions to build the building best?
Yeah, and I think it was some sort of engineering team. Yeah, really. And I don't mean to be engineering self-serving, but I'm thinking like the Manitoba Hydro building, which has passive ventilation. I mean, they have a lot of humidity up there and heat in the summer, but it's all radiant heated and cooled. There's just tremendous synergies. They're working with thermodynamics. They're working with the laws of physics, right? We're talking about waterproofing and waterproofing details, and fundamentally what we're trying to do is pretend that gravity won't force water into gaps in our building, but gravity will. It works. It still gets us.
The architects whose buildings I love, or architects in town that I love their work, I know them, I respect them as an architect. Those architects, like you said, have an affinity for the physics of building. They don't shun it off as somebody else's interest or response. I really feel like it's just a change in priority.
I do too.
Of like understanding it. And I've criticized, for example, a building saying that I think that's bad because that shading device is in the wrong place. It's a horizontal shading device on the east side where it's not actually doing anything. And the response I've heard is, yeah, but it's an architectural feature. So it's supposedly looking better. But if you understand that it's not doing what it's supposed to do, you still think that that's beautiful. And so I think if you have the knowledge of physics and solar geometry and building enclosures or whatever it is, your priorities internalize and
Absolutely.
Change.
If someone showed you a car with square tires and tried to convince you it was more lovely, you'd be like, I'm sorry, those are square tires.
Somebody who loves a Zaha Hadid building from afar because of the form or whatnot, if you brought them up close and saw the delaminating cladding, the water infiltration staining, I don't think that would the same person would see it as beautiful.
But we need to start to wrap up here. This is about the end of the time. I think most people will listen to this kind of intrigue. So for my final thought, what I'm hearing is that there is a big problem, and that in fact it's not like it's an old problem from the 70s and 80s that is starting to work itself out in general, and in fact is getting worse. I used to sometimes look at buildings as, I used to do some movie sets, work on theater commercial sets and stuff. I'm sorry, TV commercial sets. And so you had to make something look like a stone column or something like that. And sometimes I look at a home particularly, and I think someone is doing a movie set, and they're just trying to make that look enough like a single-family residence that someone else will pay the mortgage or sign the mortgage document. And then once that deed is done, everyone's like, woohoo, and they kind of walk back away. But thinking more broadly about the building industry, integrated design is quite present on everyone's mind. And I think that architects, I'm not trying to put this at the feet of architects. I can't say that, certainly not as an architect. But we're working with some fantastic architects that see that their role is to expand the dimensions or the palette of colors that they design in. I think dimensions that they design in is better, right? So there has to be ergonomics and beauty and space and flow and color and texture. All those things are still present on the architects, what they're designing with, what they're designing. But they also need to design for thermodynamics. They need to design for human comfort, thermal comfort. And they need to design for constructability and durability. And possibly now, maybe the architect, but I think the architect surrounded by a good team, there's just no way around it, is more like the architect is central or a focal point for integrated design, right?
Well, I think the architect has the ability and is in a position to do that. I don't know if they have all the talents necessary from a project management. Mm-hmm. They are passionate.
That's daunting, yeah.
You want passionate people of all aspects in the design and construction involved as a team, but you need a person, an organization that oversees the whole thing to make sure all the different conflicting aspects are brought together and reconciled.
I like it.
And when you go back to the owner's needs.
Mm-hmm. This owner's project requirement.
Is it a box store going to sell in 5 years, or is it a institutional building that's supposed to last for 100 years? Mm-hmm. Right? They're different needs, but the same passions can go into the design and construction.
Mm-hmm. Well, I know we're trying to wrap up, but what I heard there, are you saying that there's like another possibly missing role, like a systems integrator role?
Yeah, and I go back, when I say the owner, I think of the owner as that person because he has the purse strings for one thing. Mm-hmm. Because that seems to drive decisions.
But you don't mean the owner is actually the systems integrator?
No, but an owner representative can play that role.
The owner can make sure.
Sometimes you call them not construction managers, I don't know what you call them, but an integrator is a good word to use, to integrate all the design and construction aspects to make sure everybody is pulling in the same direction, focused on the same goal.
Same outcomes, yeah.
Right.
Keith, any final thoughts?
Well, just maybe one final comment about something you guys said earlier, which was let's hope it's not just that someone didn't care, but that they didn't know. And I think that truly, from all sides, that's usually the case. That usually folks that I work with on all sides of a project want the best, but just don't know of it. And so it's improving that process so that everybody learns what they need to and can value those and bring it on to the next phase that makes a big difference.
I like it. I like that a lot. Like, what represents a fantastic building? Yeah. What does it mean? Well, thank you guys. It's been fun.
Thank you.
We'll have you back.
I'll get off my soapbox now.
Good job, you guys. Shooby-dooby-doo.